Okay, Assalamu alaikum. Today we're gonna try to explain the CSES problem, DP problem, longest common subsequence. The problem says that we have two arrays of integers, and we're trying to find the longest common subsequence of these two. What is meant by subsequence out of an array, and what is meant by being common? It means okay, you can maybe just read it out. Subsequence is a sequence of an array element from left to right that can contain gaps. So what is a common subsequence? Is a subsequence that appears in both arrays. You better try to solve this problem first. Actually, that's gonna make you insightful about how to approach the problem. Maybe actually you can just take some hints from the beginning of the video and proceed with your own solution. Okay, that is the best way to solve any problem. But I'll eventually try to explain it. Okay, so let's take an example, actually, to be more clear. So let's have this one: how to make a common subsequence out of these two. Okay, let's assume this one. This is 3. Okay, actually, just by your own bare eyes, you can find out that 1, 2, and 4 is the longest common subsequence. And actually, you have another option, as I believe. You can have 1, 3, and 4. Okay, so 1, 3, 4. Okay, so these are the subsequence that you can have: the common one and the longest one. Okay, so you gotta notice that we have a small constraint over the length of the array, and actually that is pretty much good, because especially for this problem, longer array sizes might be so computationally intensive that you can not even solve the problem to some extent. Though we have a good solution for the problem that it's computationally efficient, but larger numbers are gonna be really slow with the computations. Okay, let's proceed with the explanation. Okay, so we happen to have two arrays like these, and maybe let's enlarge these two. Okay. I always say, while you are solving a DP problem, you gotta think about the most naive approach to solve this problem. Okay, so what is the most naive approach to solve such a problem? Is to get this one. You look at this one. Okay, are these numbers? Yeah. You look at this one. Okay, you observe this one. Okay, this is your own main array, or this one. Okay, it's not a big deal. So you take this as the main array, and you go to this array, and you do what? You start to build up all the combination that you could possibly have out of that array. What do you mean by that? Let's assume the array is just these two numbers. Okay, just to ease things up, because if I take all these numbers and try to create all the combinations, we're gonna stay for a long time here. Okay, let's assume these two. Okay, what are the possibilities here? What are all the possibilities out of these things? What do you mean by that? I mean, the possibilities here are 2, A2, 8, 4, 4, 8, 4, 2, 4, 8, 2. I think 3, 4, 5, 6, 7. Yeah, these are 7 possibilities. Okay, the subsequences are correspondent to the 2 to the power of n, so minus 1. Okay, why? Because you are taking it and leaving it. Okay, these are positions that you are filling out. Okay, so either you are taking the number or not taking the number. It's a 0 or a 1. Okay, so what eventually happens is that you have 2 by 2 by 2 possibilities minus 1, which is that minus 1 is corresponding to the not an option. Okay, it's not an option here. Okay, the bottom line is, you can, if you want to have all the subsequences out of this one, you'll have 2 to the power of n. Okay, and the constraint of the array size here is 1000, and so 2 to the power of 1000 is a number that you cannot compute even. Okay, so but let's proceed from this thought. Let's say that we have all the combinations. How would you approach the problem if you have all the combinations out there? Let's say for this one, this is 2 to the power of 8, which is, I believe, like close to 7,000, I think so. Not quite sure. Okay, so let's say we have all the 7 combinations out of the first array. How would you build it? And while you are looking at this array, what you're gonna do is you're gonna go like this: 4. Okay, and you're gonna go for all the arrays out there. Okay, or you're gonna go from the other side. Okay, you're gonna have the first combination out of the 7,001. Let's say it is like 1, 3, 7, 4. How would you approach that? You'll go for the last one or from the first one, whatever. Okay, but let's say we're gonna go from the last one. Okay, you're gonna go 4. Okay, what you doing here? The main array. You're gonna go, okay, we have 4 and we have 4. Great, that subsequence seems to be good, seems to be working. And you're gonna go for 7. Okay, let's look up for 7. Okay, 7, 7, 7, 7. No, we don't have any 7. So can you create that subsequence? Do you have that subsequence could be created out of this array? No. Why? Because we don't have 7 in here. This is not a possibility. Let's assume we have 4, 3, and 3. You're gonna go 4. We have 4, and then you're gonna get 3. You got 3. Okay, we have 3, and then you have another 3. Okay, you look up for the 3, and you don't have it. So this is not a valid subsequence that is common. It's a valid subsequence in the first array, but it's not a valid subsequence in the second array. And you're gonna go with all the possibilities that you have built from the first array. Okay, that seems legit and seems to be working. Okay, but the problem is you cannot create all the possibilities out there. Okay, so how to avoid that? How to avoid creating all of the subsequences out there? Okay, let's proceed. Now that we have found out that we kind of need to create all of the subsequences from the first array and somehow find out if they are valid ones in the second array. You're gonna do that till you find the longest out of these. Okay, but the problem is that you cannot create all of the subsequences from the first array and just check them. Why? Because of the complexity of the thing. So now we want to try to find some better way, and while we are solving a problem that is tagged as dynamic programming, we want to create subsequences in some manner, in some way, that builds up the answer in an efficient way, and to avoid some redundant work. That is the essence of dynamic programming. You want to build up the same exact answers, the same exact possibilities that you would have done if you used a brute force approach. But you would do that with dynamic programming. You will build things in a specific manner, in an optimized way, that avoid some redundant work and does the work in much more performant way. Okay, how would we do that? You have to think about the constraints that you have. You have subsequences you are creating. Okay, how would we create subsequences that are efficient? Okay, the subsequences that we are creating are being built. Okay, or how do we create? How will we create some subsequence? What do you mean by that? What I mean is, the first time I tried to explain that, I just went with the normal the normal binary way of doing it. 0, 1, 0, 0, and 1, 0. All of this overhead. Okay, let's do the same with the first array. How would we do that? You go like this. You go like 3 and nothing. Okay, and then you will head off and start do what? 2 and nothing here and nothing on the left. And then you will do what? You'll start a build on top of this. What do you mean by that? 2 is gonna somehow connect to 3. It's gonna create a subsequence. Okay, this is gonna be creating a subsequence. So you're gonna create a 2 and a 3. Okay, how will you proceed with this one? 1 is gonna take itself and nothing else, and then it's gonna build on top of these. It's gonna 1, and it's gonna connect to the subsequence that just had 2, or it's gonna connect to the one that had 3, or it's just gonna connect to the subsequence that had 1, 2, 3. Can you see that? We are building the subsequences here in a constructive way. These substrings were dependent on the last thing. Okay, let's say we have a substring that has nothing in it, like this one. So 2 dependent on this one, dependent on this. Okay, actually that's a bit misleading. Actually, let's neglect that idea. Okay, I just want to make it a whole idea. Okay, to have the that is a thing that you can consider as a base case. Okay, a thing that you have to do that breaks somehow the rule. Okay, let's proceed with the idea. So 2 has created its own self, and then it started to connect with the subsequences that has been just created. So we have created 3, and 2 tries to connect to the subsequence 3. It wants to enlarge the subsequence we have just built. Okay, that seems really good. Okay, and here goes 1. 1 creates its own self, and then it tries to do what? It tries to connect to the previous ones. This one, or this one, or this one. Okay, can you see the all the subsequences are built on top of each other, and actually that's a great thing. What do I mean by that? What I mean is, what if I can terminate things? What do you mean by that? What if I am able to reach to the point that I have one, and I am able to connect it to the most valid and efficient subsequence out there? What do I mean by that? What if I was able... Okay, so what are the possibilities here? You are able to connect it to subsequences of length 1 or 2. Okay, so we can have subsequences of length 1 and length 2. What if, while building up the subsequence, I just take the ones that are valid? What do I mean by that? Let's say we're gonna build out the subsequence 3. Is subsequence 3 a valid subsequence in the second array? Yes, it is. End of the line. Let's proceed with the second one. 2. Is 2 as itself, okay, so you're gonna have 2. Okay, is it a valid one? Yes, it's a valid one. So now we have this subsequence and we have this subsequence, and 2 tries to connect with the things that are just before it. So it goes to the subsequence that we have. Does it have so the subsequence that we have before is 3. Okay, that's a valid subsequence. Okay, the case that we have, so while you are building this one, you are looking at subsequences that are valid. You don't have to check them. Okay, you just want to know that 3 is here and 2 is just before this, before that subsequence. So that the subsequences that you will have, that you will look at, that were just before you have to check on something. They are valid subsequence, okay, but you have to check for something. Is that subsequence a subsequence that I'm just being the number that is before that subsequence? So you are going to look at 3, and am I as 2 a number that is just before the subsequence that starts with 3 in the second array? Yes, yes, I am. So that is a valid subsequence. Okay, we can have even more optimization in here, and here comes the tricky part. Okay, so now that you now that you said that you have this subsequence is a valid subsequence and that one also a valid subsequence. Okay, remember, okay, because I just came across that question. So why do we keep on these possibilities? Okay, just proceed with that possibility. That is the best ever. Why would we need to connect to these ones? You have to do this. Okay, you just don't go with your own example that you have now and say, okay, so I don't want 2 and 3 now. Okay, I have 2 and 3 and they seem the best answers ever. I can build off. I can build up from this point. You shouldn't be thinking about this. Why? Because yeah, you might have something like this. Let's say we have 2, 3, and we have this 4, 5, 6. Now that you have said that, okay, 2 and 3 are valid subsequence, they are a valid subsequence, and okay, let's go along with this, and you start to build 4. 4 tries to connect to things, and it sees, okay, 3 and 2, am I a 4 that is just before 2? Am I here? No, you're not. You are in here. So now you have lost the chance to create 3, 4, 5, 6. That subsequence. Because you what? Because you did what? Because you just neglected the subsequence of 3. Can you see that? So you can just go here and just the longest subsequence, you go with it, and you just neglect all of these smaller subsequences, because you could have a case like this. Okay, and here comes the essence of the solution. Okay, can you see that the best subsequence is the subsequence that starts off from the most far index in the second array? What do you mean by that? What I mean is, let's go with this idea. Okay, let me get an example. Yeah, actually this example is valid. Okay, now that we have a subsequence of 3 and a subsequence of 2, these two subsequences are of length 1. What do you mean by that? What I mean is, these two subsequences are going to be used by, let's say, 1. Okay, 1 is going to connect with 2, and 1 is also going to connect with 3. Okay, so it needs to connect to these numbers. Okay, but what is the most efficient one out of these subsequences of the same length? The most far away one, the one that has the most larger index, the one in the farthest one in the array. And why is that? Why do you want just to keep the subsequence? You want to neglect 2 and just use 3, because it gives you more opportunities. Okay, going with 2 is actually lessening the opportunities out there that you could have. Okay, so if you come across something like 4, 2 is not going to be efficient anymore. Okay, 3 is going to be efficient. Why? Because it's far in the array. It's in the most right side of the array. Okay, and actually, even if you have 4 in here, not in the middle in here, 3 is going to be efficient also. So you can neglect 2. Okay, so now what is the rule that we came up with? Is that subsequences of the same length can be unique. You can have just one single subsequence of the same length. Okay, if you have a length of 1, you have just one single subsequence that the other numbers can get connected to. So this one have either a subsequence of length 1 or length 2. That's it. No more than this. So you have 2 possibilities to get connected to. This 6 is going to have 3 possibilities, and actually even maybe we can have less than this. Okay, so it has 3 possibilities to get connected to. You don't have to preserve all the possibilities out there that could be of the same length. Why? Because you are keeping only the one that starts with the most far index in the array, because it is the most efficient. The other ones are not going to be efficient as this one. So it's kind of a greedy approach, but it works and it makes things efficient. Okay, so maybe let's recap these things for the last time, for just to wrap up the idea. We have the first array. We want to create all of the subsequences out of that array. But we can do that efficiently. How would we do that efficiently? by building the subsequences one bit at a time, okay, and with having the mindset of building subsequences that are valid subsequences, subsequences that are valid in the second array. Okay, so while you are building up, you are making for sure that you are creating a subsequence based on a subsequence that is valid. So you yourself either gonna be a valid subsequence or not a valid subsequence, and you just proceed with your own subsequence building. So now you can, so now that actually is gonna be efficient in some way. Why? Because now we are not just creating all and every subsequences in the first array, but actually it's gonna be inefficient in cases like, okay, let's say the first array is 3 3 3 3 3 3, and let's say this is like 10,000 times. Okay, this is not 10,000, this is 1,000. Okay, how would we build such a thing? You're gonna build a length of 3, and you're gonna build a length of 3 and nothing 3 and 3 3, because this is valid one. And you're gonna go with this one, so it's 3 3 3 3 nothing 3 3 3. Okay, because it's valid. Okay, let's say this is the first array, and the second array is also 3 3 3 3 3 3. Okay, this is the case where our way of building the array is going to be inefficient. So you have to add a bit of a spice to the thing. You have to do what? You have to terminate the redundant lengths. Okay, so a length like this and a length like so this is, yeah, so this one and one like this, they all should be terminated. Why? Because you don't need it. Okay, the most efficient one out of these is this one. You can build off from this one. You don't need this one, you don't need this one. So now you have removed the redundancy out of these things. Okay, what about a length of 2? Okay, we have this one, we have this one. I think this is redundant to some. Actually, this is not wrong, not right. Okay, so which one is going to be the correct one? This one. This one is going to be incorrect. Why? Because 3 now is going to, this one, let's say we are going to have, no, actually this is totally incorrect. Okay, because this is the most efficient one. You don't need the other ones. Okay. So now let's proceed to the code. Okay, the code is a bit messy, but it's efficient somehow. Okay, so you're gonna declare these variables, the size of the arrays. You're gonna get them in, and you're gonna declare vectors corresponding to the array, the first array and the second array, and you're gonna fill them up with numbers from the stdin buffer, and you're gonna declare this array. What is that array? Okay, now that we have agreed that we're gonna just declare that we're gonna have subsequences of unique lengths, or the subsequences are gonna be unique corresponding to the length. What I mean by that? What I mean is you're gonna have a length of 1, a length of 2, a length of 3, a length of 4, and you have and you'll have what? You'll have the subsequence, the most efficient subsequence of length 1. What does it mean to have the most efficient subsequence of length 1? It means the most far far plus the most far index of a valid common subsequence. Okay, what does that mean? What it means is, okay, let's say that we want to get the most efficient subsequence of length 1 in here. It's going to be this one. Okay, so this is going to be length 1, and it's going to be the most efficient one. Why is that an efficient one? Because it gives you the capabilities to have these possibilities. What do you mean by that? What I mean is, this 6 is here, so it can connect to 5. And let's say that somehow you were able to have 3 to 1 again. So the first thing, or from the first couple of attempts trying to create the most longest subsequence in these two arrays, you're gonna think, okay, it's 1, 2, 3, and actually that would be the answer till you hit 6. Once you hit 6, you're gonna change the length, the subsequence of length 1. The most efficient one is gonna be this one, and you're gonna start building up from this one. You can have 5 connecting to this one, creating the most efficient subsequence of length 2, starting from this index, and you can proceed with these, and you're going to create the most efficient one. It's going to be 1, 2, 3, 5, 6, and instead of these ones, if you are starting from right to left, you're going to have this 3, 2, 1, and this is going to be it. You're going to think, okay, this is the most efficient, but you proceed and things just flip. Okay, so here, the array in here, this is the most far index array. The index represents the length, okay, like this one, and the value inside the array represents the most far index where that length starts. So at length 1, you're going to find the index of the most far index of the valid subsequence, common subsequence. Okay, and this is the array that holds the valid string. Actually, this is not related now. Okay, what we want to focus on is to create and build up the array. So we're gonna say this. We're gonna say that the most far index in all the positions are -1. What does that mean? It means that the most far index are bad. Okay, we want to have numbers that are great or big ones. Okay, if you have an array of 1,000, you want numbers to be big as possible. Why? Because this is the most efficient subsequence, the common subsequence. Okay, and what we do here is that we set the most far index for 0. Okay, number in here. Actually, that's kind of the base case in this problem. It's going to be set to m. M means what? M means the length of the second array. And why specifically this one? Because that means this number is great. This is great one. And why is that? If you have here a number and it is set to m, it means this number is great. Don't change that number. We don't want to change it because it's the greatest ever. Okay, and what we're going to start off doing is we're going to loop on the first array from right to left. So we're going to start off from the last index to the right index, from the right index to the left index. Okay, so we're going to have this array. We're going to start off from this one going to the left. Okay, and what we are going to do is we're going to have a variable called longest so far. What does that mean? It means the longest, or the number of length, or let me think. Okay, it means the longest length you have created so far. Okay, it corresponds to the values that you have put in this array so far. Okay, so the longest so far, you're going to loop on this. Okay, so you're going to loop on the lengths that you have built. What I mean by that? What I mean is you're going to loop over the lengths. Okay, you're not going to be looping on this array. You're going to loop on the lengths, and what are you going to do with this? Okay, you're going to go to the length, and you're going to check if the number that you have from the array is a valid number in the second array, starting off from the length that you have so far. Okay, what do you mean by that? What I mean is, let's say you have, okay, so what do we mean by validating that? It's validating the number that you have, this number. Okay, let's say that we have this number. Okay, this one here. And what do you mean by validating that number? It means that is that number a number that is valid in that array, and that we can connect to some subsequence. 3 can connect to subsequence of length 0, so this is a valid connection. Okay, but is it a valid, okay, but is it a valid piece in here? Okay, is it a valid subsequence in that array? Okay, let's get checked in here. So it loops on the array and checks if this number, if that 3 is piece of this array, and you have to look out for this, that you go from right to left. Why? Because you look up for 3. Okay, do we have 3? Do we have 3? Do we have? We have 3. You cannot start from this. Why? Because if you have 3 in here, we are returning the index. You shouldn't be returning the index of the most left index. You should be returning the length of the most right one. So you're starting off from the right, going to the left, and you return the length. If it is not valid, it's going to be returning a message -1. That means, okay, it checks for the number able to build valid subsequence based on the index. So if it returns -1, it means what? It means that it cannot find the number in the array starting off from the length we are trying to connect to. What do you mean by that? Let's say we have 1. 1 can try to connect to length of, okay, let me think. It can connect to 3, or it can connect to a length of 2 and 3. Okay, so it can connect to 3, that's of length 1, or 2 and 3. Okay, so 1 can can get connected to these two, right? Okay. So if it's valid to connect to one of these, what it does is it goes here. Can I connect to 3? Yes, you can. So I'm going to create a new whole subsequence of length 2. Okay, so it's going to be 1, 3. But here comes a very interesting thing. Okay, is that the best or this one? What do you mean by that? What I mean, if I want to have subsequence of length 2, is it the best to have 1, 3 or 2, 3? 2, 3 is the best. So yes, you are able to connect it to the 3, but it is not the best idea to use that subsequence that you have just tried to create. Okay, you go to the second one. Okay, to the second possibility out there. You have a length of 2, and you can connect and create 1, 2, 3. Okay. You also, in some bureaucratic way, you go to the length just after that, a length of 4. The length of 4 here is going to be not touched before, and it will have the most far index of -1. So that is going to have a length an index of 0. Actually, 0 is best than -1, so it's going to take it. So it's going to have a subsequence of length 3. Sorry, that its first number of the sequence is starting off from 0. Okay, so this one checks for validity of the number that it tries to connect to the possible lengths. These are the possible lengths that we are looping over. We are checking if the number that you are trying to connect to has the validity to get connected. And let's say we were able to say, okay, it's valid. If it happens that the number is valid, you do what? You check if that number is larger than the length just after that. Okay, the same thing we did in here. And if that happens, we're gonna change that. Okay, you go like this one, for instance. This is of length 3. You go to the length of 3, and you change the index, the most far index. That case was 0, it was -1, and we changed it to 0. And here comes the string part. Okay, the string part goes like this. You've had just changed the thing and created a longer subsequence. Okay, you have to go with the subsequence just of length I. Now that you have just changed or created a longer subsequence, go to the subsequence that are less by 1, or in that case it's I, and take it and add to it the number that we have just added. Okay, the number itself, not the index. And what does that line do? It just maxes out the, now that we have got into that piece of code, we want to increase the longest so far. Okay, but sometimes this code works in places where we don't have to increase this. What do you mean by that? What I mean is, sometimes it's gonna work with 6. Okay, it's gonna try to create 6. So 6 goes to a length of 0, and it sees that a length of 0 is possible to get connected to, so it's going to create a subsequence of length of length 1 that starts with 6, and that index is here. Oh, it is here, sorry. Okay, this is of index 4. And actually, the subsequence, the most efficient subsequence so far, while we were building 3, 2, 1, was of length 2. So now you are now that you have now that you're gonna change the length of 1 from being 2 into 4. That happens in that block. Okay, you can just go in here and do this. You can just do this. Why? Because sometimes it's gonna happen that we have changed the most far index number or value, but we don't want to change the longest so far. Okay, so what happens is that we maximizing between longest so far and I plus 1. What does that mean? I plus 1 refers to, okay, now that we longest so far, actually I loops starting from the longest so far going down. Okay, and so the longest so far is gonna only be increased once we go into that block and we were able to increase the longest so far. Okay, I hope that's clear. Okay, and you're gonna just print the longest so far, and you're gonna print out the string in the longest so far index. Okay, I hope that was clear a bit. Okay, thank you. Salam alaikum.